Hi, my name is Juan Pablo Parra Martinez. I am a doctor from the Royal Institute of Technology, KTH, in Stockholm, Sweden, and from the Université du Maine in Le Mans, France. I just finished my PhD that was part of an international co-tutelle agreement between Sweden and France, and part of my PhD was founded by the Institut français de Suède of the French embassy here in Stockholm. I was part of the ÖMSE program, which actually allowed me to travel quite a bit between France and Sweden. For a year I traveled maybe 4 or 5 times, and my PhD advisors on both sides actually traveled also. It was actually very helpful because I managed to get that communication between the two laboratories in a very efficient way by actually being there. So I'm actually very grateful about it. My PhD project involves the design of lightweight vehicle structures. I am part of the Aeronautical and Vehicle Engineering department here at KTH, and in order to build lightweight vehicles, the industry has used more and more of this kind of materials, which are foams. This is, for example, a melamine foam. You can find this on the roof of your cars or the floor of a truck cabin. And the problem with these materials is that for too long they have been modeled as isotropic, meaning that their characteristics do not change with regards to the direction. But in reality, when you press this material in this direction, it does not behave the same as when you press it in this direction. And that actually affects quite a lot of the mechanical properties. So my PhD was actually to model this behavior from a mechanical and acoustical point of view. So here we're actually in the Marcus Wallenberg laboratory of the Aeronautical and Vehicle Engineering department at KTH in Stockholm, and we are sitting inside a semi-anechoic room. As you can see, it is semi-anechoic because the floor is solid, it does not absorb sound, but the walls do. These are made of wool, actually what you call the glass wool, and it absorbs sound. And here we do measurements, for example, for vehicle engineering. You can put a car inside and turn on the engine and measure outside the car the sound that's radiated from the engine onto the road, which is right now very, very regulated by the European Union and by Trafikverket.
So my name is Peter Goransson. I'm a professor in acoustics at Royal Institute of Technology in Stockholm. I am have been the supervisor of Juan Pablo Parra Martinez, who has been working with me under a co-tutelle agreement with the Laboratoire of Acoustics in Le Mans in France. In the around 2005, I met with Olivier Dazel, who is now a professor at the University of Laboratoire Acoustics in Le Mans. And we found that we had similar research interests, and we're working on complementary but rather close topics. So based on a previous very positive experience where we had the co-tutelles with the Conservatoire National Art et Métier in Paris, where we previously had 2 students, I proposed to Olivier Dazel that we should try to establish a co-tutelle also for Juan Pablo Parra Martinez. And this was realized, and starting a joint supervision with Olivier Dazel and myself as supervisors. We successfully managed to supervise and guide Juan to a thesis last year. And since this was a very positive experience, we have continued with another PhD student, Mathieu Gabory, who is now a co-tutelle between our 2 universities, and we plan to apply for a ÖMSE grant also to cover this collaboration in next time it is available, open for applications.